All right. Good morning, afternoon, and evening, everyone. Whoever is joining from different locations. My name is Praful, and my colleague Freddie will be doing this webinar on API 583 and updates around it, and the CUI related topics and CUI monitoring technologies. So we are waiting for a lot of people to join, and thanks for joining this. For my colleagues who are joining from Brazil, good job on the World Cup soccer yesterday, beating Scotland, and my Scottish colleagues, consolation to you. There will be another day. So we'll start with the slides. So today there are two speakers, myself, Praful Sharma, Chief Technology Officer of Corrosion Radar, and I'm also API 583 committee member. And hence I have quite a lot of information to deliver to you today. And my colleague Freddie, over to you. Just a brief.
Thank you, Praful. Yeah, my name is Freddie Talbot, Head of Business Development at Corrosion Radar, and I'm a CUI monitoring expert, having worked in the field for over 5 years now. So pleased to be here today and looking forward to an interactive session. Thanks, Praful.
Thanks, Freddie. Now the agenda for the next half an hour or so, we'll have about 20 minutes, 25 minutes of slides. I think quite a packed informative slides, so we may go rapidly on that. Secondly, then we'll take some questions which are pre-asked to us, probably 3 or 4 questions which we can address. And then obviously we will ask, if you're interested, just please do email us. We can have one-on-one meetings with you as well. So let's start with the agenda introductions today, and then API 583. We'll have updates. What is new in that? API 583 is about CUI and fireproofing, and the latest version is released in April 2026. So there are quite some changes. One of the change is introduction of CUI monitoring technology. So my colleague Freddie will talk about CUI monitoring technology, which Corrosion Radar offers, and then at the end we'll talk about API 583 alignment with CUI monitoring technology. So jumping in, and of course, if you need certificate of attendance, please do email us, and our team will be able to provide certificate of attendance if you need it. So why CUI needs its own recommended practice, which is API 583? Why it is needed? Because CUI is hidden by design. It's unseen. It's beneath the insulation jackets, invisible until the insulation is removed. So and it's pervasive and costly. So it can be anywhere, unpredictable. So people remove the insulation, do inspections. And it's very expensive. It's very uneconomic to confirm. So many times people are trying to find something in a very unpredictable nature. So overspending money. So this is a damage mechanism you cannot see, or unless you remove the insulation, or cannot cheaply confirm it. So that's why it's kind of costing industry. So that's why API have a dedicated recommended practice for it. So that's API 583. Now, history of the API 583 is it's a dedicated for CUI and CUF, corrosion under fireproofing and corrosion under insulation. The first edition was in 2014, second one was in 2021, and the latest one, 2026, and that's why we're talking now, was released in April 2026, just a few months back. There are quite some changes, and we're going to discuss those changes. I had an opportunity to be part of that committee and contribute to it. So happy about that. That after a lot of work from the various operators, it has come out in the open public. Now, bear in mind, this is a recommended practice. So on the right hand side, when we say RP, API RP 583, it's a recommended practice, which means it's not a must, it's should. So when we say should, it is a recommended. When we say shall, it is required. So this is not a shall, this is should. Guidance, it's a guidance. This particular standard helps to grasp complexity of CUI and CUF issues, from various angles, from design, from geometries, from temperatures, all the way to inspection and asset integrity, and even now monitoring. So it also provides capabilities and limitations of NDT techniques, CUI and CUF. It provides a structured approach to very quickly likelihood of failures, likelihood of risks. Obviously, full-fledged RBI is required for that. And then design, install, maintain insulation systems that avoid CUI. So what API 583 covers in general, what's in scope is external CUI of carbon steel and low steel under insulation and fireproofing. external stress corrosion cracking of various kinds, and duplex stainless steels. It also covers different types of assets like pressure vessels, piping, storage tanks, spheres, etc. But what it does not cover is atmospheric corrosion, which is not CUI, and insulated like corrosion under pipe support is very limited mention, or it's not covered in that. So the document map, there are various sections, initial sections, and then 4, 5, all the way till some annexures. This is the document map, which is also similar to the previous versions of API 583, but people who are not familiar with 583, then this is useful, that it articulates causes of damage and susceptible locations of the assets. It also touches upon what are the insulation systems and fireproofing systems, coatings, and what are their pros and cons. Inspection methods, direct and indirect inspection methods, we'll touch upon that a bit today. Design practices to minimize CUI, maintain mitigation, and then annexures are also how can you assess likelihood of CUI very quickly. Rather than going full-fledged RBI, which many times is very cumbersome, can you do it very quickly? And also insulation installation details. Coming to the third edition updates at a glance, April 2026, there are 4 main sections which have been majorly modified. The first one is insulation materials. So they have expanded the material types. It's a section 6.1 as to how different properties of materials drive the CUI risks. I think they have also captured about even carbon steel have stress corrosion cracking. Something reported in Canada. I think it's called intragranular stress corrosion cracking, reported in Canada, that on carbon steel something is happening in certain conditions. They mentioned that. Then inspection methods. I think they have reorganized the inspection methods into direct and indirect, unlike previous API 583. So direct inspections versus indirect, and new techniques have been added. This is section 7.3. They have added a new section on continuous monitoring. This is the first ever standalone sections on permanently installed monitoring systems, CUI monitoring, something which we'll touch upon today. Freddie will talk about it, which aligns with this particular section of the standard as to how CUI monitoring, continuous monitoring can help mitigate or address CUI risks. Annexure A examples, they have included some examples of how to calculate the risks or ranking of CUI potentials. Also new is CUI on aluminum piping, and ILI, or indirect inline inspection, as an indirect tool for piping. So with that introductions, I'll cover slightly more details at the end of this presentation. I'll give the floor to my colleague Freddie to talk about CUI monitoring.
Thank you, Praful, and thanks for the great introduction to the new API guideline and changes. So welcome. I'm really pleased to be here to be able to go and tell you about CRSR, a new product launch happening in July for Corrosion Radar. Before I go deeply into the product, if you can move to the next slide, please, Praful. I'd just like to give a brief overview of Corrosion Radar and our work in the field, the CUI monitoring space, for the last 10 years, a decade. During that decade, we have over 120 million data points live across our network. So this is data being picked up every single day on CUI, the vessels, the environment, the piping, and really helping to remove that hidden invisibility around CUI and bringing the visibility to our operators. We're also able to help reduce the CUI management costs, reduce inspection scope, and we're seeing, very high, large savings and reductions in consequence of failure. And this is through a decade of industry experience specializing in CUI monitoring. And we're very excited to bring that to a new product, CRSR. Next slide. So CRSR is continuous CUI screening without the insulation removal. And this is specifically designed for API 583 susceptible locations. CRSR is a plug and play, and it gives 4 key outputs which help operators make inspection decisions. We give a corrosivity rate, a moisture reading, a temperature reading, and a humidity reading. Many of our existing customers rely on Corrosion Radar to change and make inspection decisions, and this is the philosophy we brought to our new product, CRSR. Given this holistic data in a localized hotspot across susceptible locations, we can help with pre-turnaround inspection planning, and we're also capable of rapid deployment during operation. The operation does not need to be shut down. We can plug, play, connect into the local infrastructure and connectivity, and the system is live, up and running, helping you move from a position of no data to having data to help optimize your operations. In terms of the business outcomes, we can reduce unnecessary inspection scope. I think that there's a key stat that I often hear that up to 70-80% of CUI inspections are wasted. We aim to reduce that inspection, reduce that wastage to around 10-20% mark through our continuous monitoring. We'll help you prioritize the high-risk locations, protect the uptime, and increase the confidence in inspection decisions as well. Next slide. Thanks, Praful. So this is a brief overview of our two technologies. CR-SR is at the top, the plug and play, and we have the CR-LR, CR long range technology at the bottom of the screen. And we have various technology specifications. For the purpose of today's sessions and the short time, I won't go through the detail of this, but we have adaptive sensors for different vessels, different operations. And if the insulation is removed or not removed, we have the sensor type available to you to help you move from a position of no data or no data every 5 years to having continuous data every single day to really turn that CUI data into intelligence to help you improve your operations. Next slide, Praful. So what does the data do? It's all well and good having the sensors, the data, but you need action from that data to make it a worthwhile investment from your business. So number one is we gain continuous risk visibility, constantly monitoring the CUI risk across those critical assets. From that data, as I mentioned, we can help prioritize the inspection activity. We can focus the inspections on locations with the highest probability of CUI scope. With that data, we are able to reduce the inspection scope and avoid unnecessary insulation removal. We optimize the turnaround and maintenance programs. We also protect asset reliability and uptime as well. So we have the sensors, we have the data, we have the dashboard, whether through API or your own standalone dashboard. And from that, you can make operational decisions to really improve the operations on your site. Next slide, Praful. This is the vision and the scale up that many of our existing customers are taking with Corrosion Radar. A complete strategy for site-wide CUI visibility. Many customers start with those high critical vessels and pipings.
I think we may have
those.
Go ahead, Freddie.
Many of our operators are taking the sensors across high-risk vessels and piping and deploying that across many different vessels and across their scope, and continuously expanding that scope to screen the API 583 susceptible locations, prioritize and take targeted action as well. And this is an overview of the dashboard that you will see to gain that site-wide CUI visibility. Next slide, Praful. Thanks, Praful. So that was a quick recap and overview of a new product launch taking place for Corrosion Radar next month. Really excited to bring this to the market. And thank you. Back to you, Praful, for more API 583 changes.
Great. So we started with API 583 introductions, and then there was a section on CUI monitoring, and Freddie have talked about CUI monitoring technology itself. And let's talk about other changes and how inspection strategies changes with API 583. So that's so fundamentally API 583 have reframed the inspection technologies. So it's a cleaner decision-making framework. So this is about basically in this new edition they separated out direct methods and indirect methods. So the direct methods which have more confidence, a barrier removed, say inspect the surface itself, like the core surface. So visual examination, insulation, follow up with ultrasonics for wall thickness, etc., pit gauges. So this is more direct and this is more confidence. Then they have separated indirect methods, which is NDT, barriers, insulation is still in place. So without removing the insulation, it's the indirect methods. For example, profile radiography or real-time radiography, pulse steady current guided wave, neutron backscatter, and also continuous monitoring as well as a part of predictive or indirect methods as well. So these are the two categories. Now they have separated out, and every method is cross-verified by the results is delivered. Some of them are more quantitative, for example, measured remaining wall thickness, ultrasonics or pitting gauges. Some are semi-quantitative, based on band of percentage of wall loss, because not everything is very quantitative. For example, I think now they have considered post-steady current, etc., in the semi-quantitative method. And then there are qualitative assessments, like in annexure A, which can risk rank the CUI potential, is a very qualitative method. And they also updated insulation materials 6.1 section as to why different materials have different properties. So this has added depth to the conversations around CUI within API 583. Um, if it's basically there are four material classes: granular, fibrous, cellular, and insulation coatings. Now, insulative coatings is a new category, which is having a thin composite, but also there are question marks around when and where it can be deployed, because the efficiency is subjective of applications. But this leans on low temperature systems, being polyurethane or PIR, aerogel cellular materials, because they provide vapor retardant. But also for high temperature systems, they continue to talk about various cases, including mineral wool, fiberglass, the usual stuff. But water absorption is a key issue, and how each of these insulation material can wick the moisture away, which ones is chloride leaching. So there are tables around it in this new section where they've classified these materials. And what the key takeaway is, the material moisture behavior is very different for each of these insulation types. Again, the devil is in the details, and then there are specific tables which API 583 now provides, which classifies the risks related to these insulation materials. One of the biggest spotlights is on continuous monitoring. So section 7.3.3.9 introduces continuous monitoring with new technologies. So there are permanently installed sensors, be it guided wave, electromagnetic flexible sensors, which Freddie talked about. Humidity monitors, and SR is an example of that. Liquid water detector, again, SR is an example of that. It does both. It also mentions fiber optic sensing, so kind of broad range with pros and cons, because not every application is the same. So there are various applications of it. Um, and then there are different applications, like hot and cold applications may be different for different technologies. There are temperature limits, there's a resolution, etc. Example of susceptible locations of CUI where API 583 says is, let's take the example of pressure vessel. Areas of concerns are shown in the marked gray areas of vertical vessels. So they actually list this out in a table. For example, near a support ring, you can put a sensor. You can any protrusion, platform bucket or large nozzles, you can put sensors, or you can put the sensors on the main body, um, like the ones what Freddie mentioned around wire sensors or its spot sensors. And also on the top, the top of the asset is very susceptible because of water stagnation there. So this is example. Now similar examples are for piping, similar examples are for various other asset types. So these are the susceptible locations, and that's where the monitoring can help. Annexure A is updated in API 583. It assesses the likelihood of CUI. Now they have what is updated is the annexure itself is not updated in the sense of the risk ranking methodology. So basically, it's about key inputs like insulation type, insulation age, coating age, and material temperature, etc. So these are the inputs to that model. You can put it in even in Excel and make it. These are the 5 inputs, and the output is the likelihood ranking. So this is a very quick way of risk ranking a particular asset. But when you update with monitoring data, then you have a real-time visibility of this risk ranking rather than subjective. So monitoring helps in this, but in this case, Annexure A kept the overall model, but they have given some examples, worked out examples of how you can do it, um, of this risk ranking method. Now, what this means, this is the last slide before we take some questions. We have been sent some questions, so we'll take those questions. But what this means for your asset integrity program is API 583 is updated, and now there are different methods and inspection technologies, and pros and cons. But fundamentally, a big change is continuous monitoring is now named and defined inspection tool. for predictions with explicit selection criteria. It's no longer a footnote, which was earlier the case, but now they're kind of mainstream. Complements that you need not replace an insulation just for inspection, but you can have indirect methods, you can have monitoring based analytics, and then follow up the confirmation to a particular location. So basically this optimizes the inspection program. The value really comes from integration, from data management and RBI like technologies, combining with sensors. So risk ranking with sensors live, it gives inputs, uh, inspection optimization, and early movers use monitoring data to have inspection scope prioritization and extend the inspection intervals. So this is more of a territory of risk-based inspections (RBI), which is not the scope of API 583, but API 583 gives the tool sets. These are the tools to manage it, and sensors and monitoring is one of the tool sets to manage the risk. And once the risk is managed, it can be updated in RBI tools, whether the risk is reduced, etc., as a mitigation. Now, this is the category which is moving fastest. It's been in the standard, but now the sensor category is the fastest moving category. Within that sensor is the track the moisture and humidity and track the corrosivity levels of the assets with short range or long range systems, and then optimize your inspection scope and optimize your inspection intervals. So with that, we conclude our presentation slide and we can take some questions. Obviously, you have chat window to post some questions. Before we take some questions and jump into it, our ask is my colleague Freddie will be very happy, and myself, if based on availability, we'll be very happy to have follow-up conversations with any of you if you're interested to know more, because today was a very short time. We just touched the surface. There are so many case studies and proven value cases across the globe, which we can talk about. So please feel free to reach out to us, as well as feel free to reach out to us for your certificate of attendance. With that, Freddie, over to you for questions.
Thank you, Praful, and thanks for the great session on the new API guidelines. So I've got a few questions to run through with you. So I'll start with this one. So this was pre-submitted early this week, I believe. So how does the new API 583 influence daily inspections, maintenance, and operation? That's a question for you, Praful.
Yeah, so API 583 is a very practical, very pragmatic methodology. For a particular plant, for example, if you're a plant inspector, if you're not using it already, it gives guidance on the susceptible locations. The one example I showed was a vessel, the key locations where CUI may happen. They also give examples of guidance of where in the piping it can happen. For example, lowest points or highest points, manholes, drains, any geometrical changes, and they list out all those typical scenarios. So this is more practical, where to inspect, where to look for. The problem is, that the number of such locations are just too much in a typical plant. So how can you optimize it? They don't give that guidance of optimization. They just give a guidance on where to look for, what are the susceptible locations. And once you have identified those susceptible locations, what are the direct and indirect inspection tools like visual inspection or NDT, and what are the pros and cons? Uh, but the judgment is of the inspectors, you know, with this guidance. They also give a risk ranking based on temperatures and 5 factors, which I mentioned. They have a methodology in Annexure A as to how you can prioritize one location than the other, even within their susceptible locations, but how you can prioritize as well. Some can be faster inspection, some can be lower inspection. So this is more practical guidance it provides. But as far as RBI is concerned, RBI is a separate territory, API 581. Ready? Second.
Thank you, Praful. Second question. Are digital sensors and AI becoming the new standard assessment tools?
I would say more and more. There are so many advancements recently. I mean, you talked about, Freddie, one of the big advancements is the sensor technologies, right? Plug and play sensors, wireless technologies is rapidly scalable, battery powered systems and dashboard, etc. Right? So sensors are available now for CUI purposes. Sensors are now available, and it's been available for the last 10 years. And now API standards are actually putting that as one of the viable tools to manage. So they're there, but they are not there in standalone. I mean, they are the information. You still have to inspect You still have to do NDT and visual inspection, but these tools can help optimize those locations. CMLs, for example, they can help optimize those locations, where to inspect, where not to inspect. As far as AI and digital tools are concerned, we are seeing, I mean, I would say RBI is an example of analytics. It's a tool, but now how can we do more predictive analytics with all this inspection, NDT, all this data which is available. So risk methodologies are becoming more and more rapid and fast and accurate with a lot of these AI tools which are becoming available. So we are just in the early phases of that. So I would say sensor technologies are more advanced in that, and AI tools are becoming available, and there's so much of potential there.
I agree. It's taking the data and making informed decisions based on that data. I agree.
That's right.
Third question I like, it's quite provocative. Any coating technology in development to take care of CUI and get rid of those sensor technologies? What do you say to that, Praful?
Yeah, so I mean, the best scenario would be no corrosion, no CUI, right? So I would say best insulation systems are trying to do protection much at the level at best they can, but still CUI is happening. The best coating systems, I would say TSA is considered among the best, but we also hear that thermally sprayed aluminum, for example, is considered best for CUI, but it's also expensive. So when we say best technologies and protection, I would say best technologies will avoid CUI, and coatings is an example of a thermally sprayed aluminum, but it's expensive, and in the field is a question mark as to how you can have quality control, because these are all very dependent on quality control. So I would say coatings is a must. We can't go away with coatings, but the efficacy of the coatings is always a question mark, mainly because the actual field conditions may be deviating from what they're designed for, right? For example, cyclical acids and temperatures, chlorides leaching, etc. The coatings gets affected by that. So coatings are a must, but then we are never sure, and hence sensor technologies are not a replacement for coatings. In fact, sensor technology is an added on layer, data layer, I would say. It's a data layer to protect the assets over and beyond coatings. So it's a complementary set rather than a competing set.
Thank you, Praful. I think we have time for one more question. I'm going to take the question from the chat. It's from Jose Jordan. Thanks for the question, Jose. So the question is, these sensors monitor the CUI. Are they the right size and shape to fit the CML geometry?
Freddie, I think this question is about LR, SR, because SR is more geometry agnostic. So probably you may want to talk about it.
Yeah, it's a great question, Jose. So I think, yeah, our sensors are designed with our operators and customers in mind to fit the CML geometry. So I'm happy to take this offline and have a further conversation and really show you how we've designed the technology to fit our customers and our operators' criteria and choices for these sensors. But no, it's a really good question. I appreciate that question. Yeah.
Thank you. So I think we are reaching the end of the session. Thanks for attendance. And I've been told that you'll be sent a link with the video recording, and as well as a PDF of the slide pack. So please watch out for that link. And then if you have any further interest and questions, please feel free to reach out to any of us. Thank you very much, and have a great day.
Thank you all. Thank you, Praful. Goodbye.